This small board is measuring real-time battery power. But the real question is, how accurate is it? Let's compare it with a clamp meter. So in this video, I'm building and testing a complete battery power monitor. For measurement, I'm using the INA226 sensor. This sensor can measure both voltage and current very precisely using I2C. I'm adding header pins so it can be easily connected and tested on a breadboard. This step is simple, but it's important for stable connections. Compared to simpler sensors, this one offers better accuracy and resolution. This is the Tuya T5-E1 AMOLED development board, which makes it perfect for integrating sensors like the INA226. There's also a physical button for user interaction. There's also a micro SD slot, which can be used for data logging or storage. At the top, we have access to GPIO and I2C pins. It includes a microphone and speaker interface, which makes it suitable for interactive or AI-based projects. It also supports battery input for standalone operation, and a USB-C port for power and programming. Inside, we have the main board with the integrated T5 module. This is the core of the system, handling processing, connectivity, and communication with sensors. It features a 1.75-inch AMOLED display with a resolution of 466 by 466, which is perfect for building a clean real-time dashboard. The touch response is smooth and fluid, and the display is sharp and easy to read. First, I'm adding header pins to the board, then mounting it on the breadboard for quick prototyping. Now connecting the INA226 sensor using I2C. This requires only 4 wires, power and communication lines. Now powering the system through USB and uploading the firmware. The code reads voltage and current from the sensor and calculates real-time power. Once uploaded, the system starts displaying the data. This line connects to the system voltage, so the sensor can measure the battery voltage. Now I'm adding a 12-volt 5-watt load to the system. And here we measure the small voltage drop across the shunt to calculate current. The load is now active. Test load, 12 volt, 0.3 ampere, 4 watt. The readings are very close. So far, the system works well for small loads. But for real battery systems, we need to handle much higher current. One advantage here is that it supports Tuya Open, which makes it easier to build and expand real hardware projects. Now let's take it to the next level. This is a 100 amp precision shunt, allowing accurate current measurement at higher loads. Its resistance is extremely small, so it's not easy to measure accurately with a standard multimeter. Instead, we measure the voltage drop across the shunt and use it to calculate the current. Now I'm applying a higher load to test the system. And now we can see the real-time measurements. Starting with a moderate load, the system is measuring around 1.7 amps. And compared to the clamp meter, the reading is very close. And this matches the power supply readings as well. Now let's push it further with a higher load. With a higher load, the current increases significantly. And the system continues to track it in real time. And again, the readings are very close to the clamp meter. At higher current levels, the measurement becomes even more stable and reliable. For the final test, I'm switching to a real battery system to push the setup to higher current levels. This inverter is driving a high-power load. Now I'm applying around 700 watts of load. And this is where things get interesting. The system responds in real time, and the indicator smoothly rises with the current. At around 60 amps, the readings are still very close. Now let's push it even further. Now we're above 100 amps, and the system is still tracking the current accurately. This confirms that the external shunt solution works reliably even at high current. From small loads to over 100 amps, this system proved to be stable and accurate, turning a simple board into a real power monitoring solution. And with the Tuya T5 platform, it's easy to build and expand projects like this. You'll find all the links in the description, including the development board, Tuya Open, GitHub, and their Discord community for support and projects if you want to try it yourself.